Spring Security Guide in Cloud Native Applications. Introduction. Spring Security is a powerful security framework used to protect Spring Boot applications with authentication, authorization, and protection against common attacks. Cloud native applications often use Spring Security for REST API security, JWT authentication, OAuth2 Resource Server, role-based access control, scope-based authorization, Microservices security, API gateway security, Kubernetes deployments, secrets management, CORS configuration, method-level security, production API protection. A common learning topic is how can backend and full-stack developers use Spring Security in cloud-native applications? This guide explains Spring Security Basics, Cloud-Native Security Architecture, JWT, OAuth2 Resource Server, SecurityFilterChain, CORS, CSRF, role-based access, method security, API gateway security, microservices security, Kubernetes secrets, Docker deployment, observability, best practices, interview questions. Spring Security is the standard security framework for Spring applications and provides authentication, authorization, and protection against common attacks. Simple definition. Spring Security is the security layer that protects Spring Boot APIs. Simple idea. Client request, Spring Security filters, authentication check, authorization check, controller, service, database. Cloud native example. React, Angular, frontend, API gateway, Spring Boot, resource server, JWT validation, microservices, PostgreSQL. Why Spring Security matters in cloud-native apps. Cloud-native applications usually have caller, multiple services, public APIs, front-end apps, mobile clients, containers, Kubernetes, API gateways, service-to-service calls, secrets, external identity providers. Without security, APIs can be accessed without permission. Admin endpoints may be exposed. Tokens may be accepted incorrectly. Services may trust unsafe requests. Secrets may leak. Front-end only security can be bypassed. With Spring Security, APIs require authentication. Role/scopes protect endpoints. JWTs are validated. CORS is controlled. Method security protects business logic. Microservices can validate tokens. Cloud deployments become safer. Spring Security Architecture. Spring Security uses a filter chain. HTTP request, security filter chain, authentication filters, authorization filters, controller. Spring Security's servlet support is based on filter chain proxy, which delegates to security filters through SecurityFilterChain. Cloud-native security architecture. Typical architecture. Browser/mobile app, down to identity provider, down to access token, down to API gateway, down to Spring Boot microservice, down to database/cache/message broker. Example stack: React frontend, Keycloak, Okta, Azure AD, JWT access token, Spring Cloud Gateway, order service, PostgreSQL core concepts, concept meaning, authentication, who are you, authorization, what can you access, principal authenticated user service, role user permission group, scope OAuth2 permission, JWT, signed token containing claims, resource server API that validates access tokens, security filter chain, Spring security filter configuration, CORS, browser cross-origin access control, CSRF, cross-site request forgery protection. Step 1. Add Spring Security dependency. Maven. Dependency, group ID, org Spring Framework.boot, group ID, artifact ID, Spring Boot Starter Security. For OAuth2 Resource Server, dependency, group ID, org Spring Framework boot, group ID, artifact ID, Spring Boot Starter OAuth2 Resource Server, artifact ID. For JWT support, dependency, group ID, org Spring Framework Security, artifact ID, Spring Security OAuth2 JOSI, Spring Security supports OAuth2 Resource Server with JWT and opaque bearer tokens. Step 2. Basic Security Filter Chain. Modern Spring Security uses SecurityFilterChain. Configuration: @enable web security, public class security config. Bean SecurityFilterChain, SecurityFilterChain, HTTP throws exception. Return http.authorize HTTP requests. auth.request matchers API public / permit all. Request matchers actuator health permit all. Any request authenticated. Meaning API public / API is public. Health endpoint is public. All other endpoints require authentication. Step 3. Stateless API security. Cloud-native REST APIs are usually stateless. Bean SecurityFilterChain, SecurityFilterChain, HTTP security HTTP throws exception. Return http.session management session.session creation policy stateless. Authorize HTTP requests auth.request matchers API public.chance permit all. Any request .authenticated build. Stateless means server does not store login session. Client sends token with each request. Step 4. JWT Resource Server. Configuration. Spring Security OAuth2 Resource Server JWT Issuer URI https auth.example.com realms my realm. Security config. Bean SecurityFilterChain, SecurityFilterChain HTTP security HTTP throws exception. Return http.authorize HTTP requests auth.request matchers API public ... permit all. Any request .authenticated. OAuth2 Resource Server OAuth2 JWT Customizer with defaults. Build. Spring Boot can auto-configure a security filter chain for OAuth2 Resource Server JWT validation when the correct dependencies and properties are present. Step 5. JWT Request Flow. Client gets access token. Client calls API with token. Spring Security validates JWT. Issuer checked, signature checked, expiry checked, authorities extracted, request allowed or denied. Header.
Authorization.
Bearer EYJHB GCIO. Step 6. Protect endpoints by scope. Example. Bean SecurityFilterChain, SecurityFilterChain, HTTP security, HTTP throws exception. Return http.authorize HTTP requests auth request matchers http method.get /API orders / has authority scope read orders. Request matchers http method post API orders / has authority scope write orders. Request matchers API admin / has authority scope admin. Any request authenticated and OAuth2 Resource Server OAuth2 to OAuth2 JWT Customizer with defaults. Meaning get orders needs read orders. Post orders needs write orders. Admin APIs need admin scope. Step 7. Protect endpoints by role. Roles are usually mapped as role user, role admin, role manager. Example. Bean SecurityFilterChain, SecurityFilterChain HTTP throws exception. Return http authorize HTTP requests. Auth request matchers API admin SSS has role admin. Request matchers API users SSS has any role user admin. Any request authenticated. Important. Has role admin checks for authority role admin. Has authority admin checks for authority admin exactly. Enable method security. Configuration @enable method security, public class method security config. Service method @service, public class order service. @pre-authorize, has authority scope read orders. Public list order response, get orders. @pre-authorize, has role admin. Public void delete order, long orderide. Spring Security supports method-level authorization using annotations on methods, classes, and interfaces. Step 9. Controller versus service security. Controller security. Get mapping. API admin users. At pre-authorize has role admin. Public list user response get users. Return user service get users. Service security. At pre-authorize has role admin. Public list user response get users. Return user repositories.findall.stream.map user mapper.toResponse. Best practice. Protect routes at HTTP layer. Protect critical business actions at service layer. Why? Service methods may be called from other controllers, scheduled jobs, events, or internal workflows. Step 10. Cores in cloud-native apps. Front-end and back-end usually run on different domains. Example. Front-end, https://app.example.com. Backend, https://api.example.com. Cores config. At bean, course configuration source, course configuration source. Course configuration config equals new course configuration. Config.setAllowedOrigins. List of https app.example.com. Config.setAllowedMethods. List of get, post, put, delete options. Config.setAllowedHeaders. List of authorization, content type. Config.setAllowedCredentials true. URL-based course configuration source. Source equals new URL-based course configuration source. Source.register course configuration. /config. Return source. Enable insecurity. Bean. SecurityFilterChain, SecurityFilterChain. HTTP throws exception. Return http.course customizer with defaults. Authorize HTTP requests. Auth any request authenticated. OAuth2 Resource Server, OAuth2 JWT, customizer with defaults. Spring Security Documentation notes that CORS is browser-based and must be enabled configured correctly for cross-origin browser applications. Step 11. CSRF in REST APIs. CSRF matters when browser cookies automatically authenticate requests for stateless token-based REST APIs using authorization headers. Bean. SecurityFilterChain, SecurityFilterChain. HTTP security HTTP throws exception. Return HTTP, CSRF disable. Session management, session creation policy, stateless. Authorize HTTP requests, auth any request authenticated. OAuth2 Resource Server, OAuth2 JWT, customizer with defaults. Important. Disable CSRF only when appropriate. For cookie-based browser sessions, CSRF protection is usually important. Spring Security provides support for protecting against CSRF attacks. Step 12. Public versus protected endpoints. Common public endpoints. Get/actuator/health. Get/API public. /post/API auth login. Post/API auth register. Protected endpoints. Get API users me. Get API orders. Post API orders. Get API admin X. Example. Authorize HTTP requests. Auth at request matchers, actuator health, permit all. Request matchers, API public, permit all. Request matchers, API admin, permit all. Any request authenticated. Step 13. Secure actuator endpoints. Recommended. Actuator health means public or limited. Actuator info means optional public. Actuator metrics means protected. Actuator env means protected or disabled. Actuator beans means protected or disabled. Example. Authorize HTTP requests. Auth request matchers dot actuator health permit all. Request matchers dot actuator / has role admin. Any request authenticated. Why? Actuator endpoints can expose operational details. Do not expose sensitive endpoints publicly. Step 14. JWT claims mapping. JWT example. Sub. User 101. Scope. Read orders, write orders. Roles. User, admin. ICE. HTTPS auth.example.com. Odd. Order API. X. 173000. Spring security often maps scopes to scope, read orders, scope, write orders. For custom role mapping, Bean, JWT Authentication Converter, JWT Authentication Converter, JWT Granted Authorities Converter, Scopes Converter, equals new JWT Granted Authorities Converter, Scopes Converter, Set Authority Prefix, Scope _ Scope, Set Authorities Claim Name, Scope. JWT Authentication Converter, Converter equals new JWT Authentication Converter. Converter.set JWT Granted Authorities Converter, Scopes Converter. Return Converter. Use .OAuth2 Resource Server, OAuth2, OAuth2.jwt, JWT.jwt Authentication Converter, JWT Authentication Converter. Step 15. Validate issuer and audience. Issuer means who issued the token. Audience means who is this token intended for. Good practice. Validate issuer, validate audience, validate expiry, validate signature. Example audience validator. @Bean, JWT decoder, JWT decoder. Nimbus JWT decoder, JWT decoder equals JWT decoders.from issuer location, https://auth.example.com. OAuth2 token validator, JWT, audience validator equals JWT parentheses, list of string, audiences, JWT get audience. If audiences.contains order API, return OAuth2 token validator result success. OAuth2 error equals new OAuth2 error, invalid token. Token audience is not order API. Return OAuth2 token validator result failure error. OAuth2 token validator, JWT validator, new delegating OAuth2 token validator. JWT validators create default with issuer, https://auth.example.com. JWT decoder, set JWT validator. Return JWT decoder. Step 16. API Gateway Security. Cloud-native apps often use an API gateway. Front-end, API gateway, order service, payment service, inventory service. Gateway responsibilities. COP. Route requests, validate tokens, rate limit, apply cores, add correlation ID, centralize edge security. But important. Do not rely only on gateway security for sensitive services. Critical microservices should still validate tokens or trust gateway only through strong internal controls. Step 17. Service-to-service security. Microservices may call each other. Options. Yes, propagate user JWT, client credentials flow, MTLS between services, service mesh identity, internal API tokens, Kubernetes network policies. Example? Order service down, payment service. For user context calls. Propagate access token with user permissions. For machine-to-machine calls. Use client credentials flow. Step 18. Security in Kubernetes. Cloud-native Spring Boot apps usually run in Kubernetes. Security areas. Kubernetes Secrets, config maps, service accounts, RBAC, network policy, container security context, image scanning, TLS certificates, external secret manager. Kubernetes recommends restricting secret access with least privilege, enabling encryption at rest, and limiting who can create pods that can read secrets. Step 19. Kubernetes Secret for Spring Security Config. Secret. API version v1, kind, secret. Metadata. Name, security secret. Type, opaque. String data. OAuth2 issuer URI. https://auth.example.com. JWT audience. Order API. Deployment. Env. Name. Spring Security OAuth2 Resource Server, JWT issuer URI. Value from secret key ref. Name. Security secret key. OAuth2 issuer URI. Important. Do not commit production secrets to Git. Use external secret managers when possible. Step 20. Docker security for Spring Boot. Docker file. From Eclipse Temurin 21 JRE. Workdir app. Copy target order service.jar app.jar. Expose 8080. Entry point java-jar app.jar. Better production version. From Eclipse Temurin 21 JRE. Run user add-r spring. Workdir app. Copy target order service.jar app.jar. User spring. Expose 8080. Entry point java jar app.jar. Why? Run container as non-root when possible. Step 21. Security headers. For browser-facing apps, security headers matter. Examples. Content security policy. X content type options. Strict transport security. X frame options. Refer policy. Spring security config idea. Bean. SecurityFilterChain, SecurityFilterChain, HTTP security HTTP, throws exception. Return HTTP, headers. Headers frame options, frame same origin. Content type options, customizer with defaults. Authorize HTTP requests, auth any request, authenticated. Use security headers especially when serving web pages or browser-facing APIs. Step 22. Password encoding. If your app stores user passwords, never store plain text. Use password encoder. Bean. Password encoder. Return new bcrypt password encoder. During registration. String encoded password equals password encoder.encode, parentheses. During login. Boolean matches equals password encoder.matches. Raw password, user.getPassword hash. Important. Store password hash, not password. Step 23. Authentication provider example. For custom username password login. @service, public class custom user detail service, implements user detail service. Private final, user repository. Public custom user details service, user repository. This.user repository equals user repository. Override. Public user details, load user by username, string email, throws username not found exception. User equals user repository.find by email. Or else throw new username not found exception, user not found. Return org.springframework.security.core.userdetails.user with username.user.getEmail, password.user.getPassword hash, authorities.user.getAuthorities. Cloud native note. For enterprise apps, prefer external identity providers when possible. For internal custom systems, secure password handling carefully. Step 24. Rate limiting. Spring Security does not provide full API rate limiting by itself. Common places for rate limiting. Check. API gateway, ingress controller, service mesh, reverse proxy, Redis-based rate limiter, cloud WAF. Example protection. Limit login attempts. Limit password reset requests. Limit public API requests. Why? Authentication endpoints are high risk and should be protected. Step 25. Observability and security logs. Security logs should capture. Check. Login success failure. Access denied. Invalid token. Expired token. Missing scope. Admin action. Suspicious request patterns. Correlation RD. Example. @l/fsw. Component public class. Access denied logger. Public void log denied access. String user, string path. Log.warn, access denied, user path. Avoid logging. NUC, passwords. NUC, full JWT tokens. NUC refresh tokens. NUC session cookies. Private user data. Step 26. 401 versus 403. Very common interview topic. Status, meaning 401, unauthorized, not authenticated. 403, forbidden, authenticated but not allowed. Example 401. No token, invalid token, expired token. Example 403. Valid token, but missing admin role. Valid token but missing right order scope. Step 27. Testing Spring Security. Add test dependency. Dependency, Group ID, org Spring Framework Security. Group ID, Artifact ID, Spring Security Test. Artifact ID, Scope, Test. Test role. Test, with mock user, roles admin, void admin should access admin endpoint, throws exception. Mock MVC, perform, get API admin users, and expect, status, is okay. Test forbidden. Test, with mock user, roles equals user, void user should not access admin endpoint, throws exception. Mock MVC, perform get API admin users, and expect status is forbidden. Step 28. Testing JWT security. Mock JWT. Test. Void should allow order read scope, throws exception. Mock MVC. Perform get API orders. With JWT authorities new simple granted authority, scope read orders, and expect status is okay. Missing scope. Test. Void should reject missing scope, throws exception. Mock MVC perform post API orders. With JWT authorities new simple granted authority, scope read orders, and expect status is forbidden. Step 29. Real-world cloud-native example project. Secure order management microservice. Architecture. React frontend, Keycloak login, JWT access token, API gateway, order service, PostgreSQL. Spring security responsibilities. Check. Validate JWT. Protect APIs. Enforce scopes. Enforce roles. Secure actuator. Enable cores. Disable CSRF for stateless API. Log security events. Support method security. Kubernetes responsibilities. Store config. Secrets safely. Restrict network traffic. Use service accounts. Protect ingress. Use TLS. Scan images. Run as non-root. Step 30. Recommended project structure. SRC main Java, com example security. Config, securityconfig.java, courseconfig.java, and jwtconfig.java. Controller, ordercontroller.java, admincontroller.java. Service, orderservice.java. Security, custom JWT authentication converter.java. Vi, correlation ID filter.java. Vi, exception. Vi, global exception handler.java. Common beginner mistakes. 1. Disabling security during development and forgetting it. Bad. Any request. Permit all. Better. Only public endpoints should be public. Everything else should be protected. 2. Relying only on front-end security. Bad. Hide admin button in React only. Better. Backend must enforce admin role. Front-end checks improve UX. Backend checks provide real security. 3. Accepting JWT without audience validation. Bad. API accepts any token from same issuer. Better. Validate token audience is intended for this API. 4. Exposing actuator endpoints. Bad. Public actuator env. Public actuator beans. Public actuator config props. Better. Expose only health publicly. Protect or disable sensitive actuator endpoints. 5. Hard coding secrets. Bad. Client secret, my secret. Better. Use Kubernetes Secret, External Secret Manager, or environment variables. 6. Wrong cores configuration. Bad. Config.set allowed origins. List of star. Config.set allow credentials true. Better. Use explicit trusted front-end origins. 7. Confusing roles and scopes. Roles. Role admin, role user. Scopes. Scope, read orders. Scope write orders. Use them intentionally. Best practices. Use OAuth2 Resource Server for cloud-native APIs. Prefer external identity provider. Validate JWT issuer. Validate JWT audience. Use short-lived access tokens. Enforce authorization on backend. Use method security for critical business logic. Configure cores explicitly. Disable CSRF only for stateless token. APIs protect actuator endpoints. Avoid logging tokens. Store secrets outside source code. Use Kubernetes secrets carefully. Run containers as non-root. Use TLS everywhere. Apply least privilege. Test security rules. Monitor 401-403 spikes. Document public protected endpoints. Spring Security interview questions. 1. What is Spring Security? Spring Security is a framework for authentication, authorization, and protection against common attacks in Spring applications. 2. What is authentication? Authentication means verifying who the user or service is. Example: user logs in with credentials or sends JWT. 3. What is authorization? Authorization means deciding what the authenticated user can access. Example: only admin can access /API admin/. 4. What is SecurityFilterChain? SecurityFilterChain defines Spring security filters and authorization rules for HTTP requests. 5. What is OAuth2 Resource Server? A resource server is an API that validates bearer tokens and protects resources. Spring Security supports JWT and opaque tokens for OAuth2 Resource Server. 6. What is JWT? JWT is a signed token format that can contain claims such as subject, issuer, audience, scopes, and expiry. 7. What is the difference between role and authority? Authority is a permission string. Role is a special authority, usually prefixed with role. 8. What is the difference between 401 and 403? 401 means not authenticated. 403 means authenticated but not authorized. 9. What is CORS? CORS is a browser security feature that controls whether a frontend from one origin can call an API on another origin. 10. What is CSRF? CSRF is an attack where a malicious site causes a browser to send unwanted authenticated requests. 11. When can CSRF be disabled? Usually for stateless REST APIs that use authorization headers instead of cookies. But for cookie-based browser sessions, CSRF protection is usually important. 12. What is method security? Method security protects service methods using annotations like @pre-authorize. 13. How do you protect microservices? Use JWT validation, OAuth2 scopes, service-to-service authentication, API gateway, MTLS service mesh where appropriate, network policies, and least privilege. 14. How do you handle secrets in Kubernetes? Use Kubernetes secrets carefully. Restrict access with RBAC. Enable encryption at rest, and prefer external secret managers for production. Kubernetes recommends least privilege access to secrets and encryption at rest. 15. Should actuator endpoints be public? Usually, only health may be public. Sensitive actuator endpoints should be protected or disabled. Spring Security Roadmap for Cloud-Native Developers, Beginner Level. Learn. Authentication, authorization, security filter chain, roles, public protected routes, password encoding. Build. Basic secured Spring Boot REST API, intermediate level. Learn. JWT OAuth2 Resource Server, scopes, course, CSRF, method security. Build. JWT secured Spring Boot API with React frontend, advanced level. Learn. API gateway security. Microservices token propagation. Audience validation. Kubernetes secrets. Service-to-service security. Observability. Zero trust patterns. Build. Cloud Native Secure Microservices System, 30-day learning plan week 1. Spring Security Basics. Learn. Current security filter chain. Permit all. Authenticated. Roles. Authorities. Password encoding. Practice. Build simple secured REST API. Week 2, JWT and OAuth2. Learn. Key costs. OAuth2 Resource Server. Key costs, JWT validation. Key costs, issuer URI. Key costs, JWT claims, 401 versus 403. Practice. Secure APIs using JWT access tokens. Week 3, full stack security. Check, React Angular frontend calls. Check, authorization header. Check, CORS, CSRF. Check, method security, security testing. Practice. Build frontend plus Spring Boot protected API. Week 4, cloud native security. Learn. API gateway. Check, Kubernetes secrets, RBAC basics, network policy, actuator security, monitoring security events. Practice. Deploy secured Spring Boot app to Kubernetes. Real-world project. Secure cloud-native order API. Features. Check. Public health endpoint. Check. Protected order endpoints. Check. Admin-only endpoints. Check. JWT validation. Check. Scope-based authorization. Check. Method security. Check. CORS for frontend. Check. Actuator protection. Check. Kubernetes secret config. Check. Docker non-root container. Architecture. React, frontend. Delete, identity provider. API gateway. Spring Boot order service. PostgreSQL, Kubernetes. Endpoints. Get actuator health. Get API orders. Post API orders. Get API admin orders. Security rules. Actuator health means public get. API orders means scope read orders. Post API orders means scope write orders. API admin / means role admin. Spring security is essential for cloud-native Spring Boot applications. Important concepts include capital SecurityFilterChain, capital authentication, capital authorization, capital JWT, OAuth2 Resource Server, capital scopes, capital roles, capital method security, CORS, CSRF, actuator security, API gateway security, service-to-service security, Kubernetes secrets, Docker security, observability, security testing. Backend developers should remember, cloud-native security is layered. Do not rely on only one protection point. Key idea. Spring Security protects Spring Boot APIs in cloud-native systems by validating identity, enforcing permissions, and integrating with modern token-based and microservice security patterns.